Welcome to the session to introduce the NetCore on the Raspberry Pi. And I believe we can start, right? Okay. You have the mic.
Yeah, everyone, please welcome Raffaele.
Thank you. So, who am I? I am Microsoft MVP, but you know, Microsoft is no more evil. This is the news. They open sourced everything. Yeah, they are working on the wild. They are opened .NET Core completely. We'll discuss this in a moment. And I am enjoying spending a lot of time in discussing this thing with communities all around the world. And I spend time in going from one conference to another, but you know, I also have to work. So I spend time with customers in various industries. I had a really good time in dealing with the financial sector. No, I'm joking. With racing, okay? The racing is something incredible because you go in production in a minute. I mean, it's something that you have to really care about the quality. And but also manufacturing is so tricky to adjust and to design the things that goes there. So and I can tell you that .NET in this case is astonishing, evolving in a way that I love so much. So this is my message. And beyond that, 2 weeks ago, we were together with Dennis at the MVP Summit. We are in deep touch with the teams. It's a pleasure to discuss with them all the things that are next. So it's a good previews of what is coming. And here we are. So what is .NET Core? Basically, it is a fork of the .NET framework. And Microsoft decided to open completely. So why it is a fork? Because they really needed to create a new version in order to avoid backward compatibility in modifying the existing one. When you have millions and millions, hundreds of millions of installations, you cannot simply change something that maybe is also have some problems in performance or something like that, because you risk to break the compatibility with the existing customers. So the idea was not that there was something fault in the old .NET framework, but simply they could not bring the best to the other platforms simply recompiling the existing or even modifying few bits. It was so risky that it wasn't worth the pain. So they decided to fork the code base. They published the entire code base on GitHub, where they are accepting pull requests from the wild. I mean, any one of us can make changes and submit pull requests. And you know what? Roughly half the pull requests are coming from the external instead of internally from Microsoft. So it's astonishing good work that I did to involve the communities in changing and evolving and improving the code base. And if you look at the .NET blog, you will see that there are huge improvements they could do on the base class libraries as well. For example, you have improvements in list, in queue, in things that touch the concurrency and things that you will never imagine that was also possible to improve. But that was possible just because they started from scratch. I mean, there is nothing that they could risk to break. And this is awesome, because when you start from scratch, you are brand new. No? It's like Dylan said yesterday night, that you can write the new code, and you can begin from scratch and start in something that you are not afraid to do something wrong. And the new .NET Core story is important because now we have also additional pieces. First of all, the .NET Core targets the server side. So you have something that is not meant to build new UIs. It's not meant to give Windows form or WPF or things like that. It's basically, at the moment, we just have a huge code set that is very useful to create server-side application like ASP.NET. But ASP.NET was, let's say, old as well. So they created a brand new ASP.NET Core. Let's say that you can migrate the application, but there are many new concepts that are very interesting. There is an IOC embedded inside. You can use your own if you will. And there are lightweight pieces of the stack. And the brand new kernel web server, the Kestrel web server, that is very lightweight and can be compared to Express from Node, just to make you understand the idea. So it's something that is completely standalone, and you don't need IIS. They didn't port IIS to the Windows web server to Linux, for example. No, but we have a very small, lightweight HTTP server that deals with everything. And if you want, you can also put Nginx in front of the application in order to support the usual server-side cases that you want. And of course, there are many other cases like the Universal Windows Platform. You may be interested or not, it doesn't matter. But there are very, let's say, workload that can be used over the .NET framework. So there is an ecosystem that is growing. And we are here to talk about the embedded ecosystem. That is very interesting because they could port this stuff not only on Linux, because we are talking about IoT on Linux, but also on ARM, so other CPUs. And that's extremely interesting because they are, of course, working on many other scenarios that are improving. And with the 2.1, I give you this kind of preview that is already on the internet, is we have also the SDK on the Pi. So you can develop inside the Pi itself. That's very easy. If you want to make some testing at home, it's extremely easy to do it. And then we have a surprise because you can also have Docker on the Pi, which is really astonishing when you see it. When we talk about IoT, it's extremely interesting to talk about the devices and the things you can do here. But if you are not very practical with the hardware, there is one important thing to say. So every modern operating system is a full-fledged operating system. And so it is basically not a real-time operating system, okay? If you look at the blue sensor is a sensor of humidity and temperature. It's very cheap, it's very common. You can find on AliExpress, okay? You can find that. And you will discover that you can simply receive and transmit data, basically receiving the temperature and humidity with a single wire, which is very important because you don't lose anything and you don't waste the GPIOs. But there is a problem, that it's very time sensitive. So if there is something wrong because meanwhile another process is doing something, you discover that it's possible not for Windows, not for Linux. There is no operating system that can be really 100% dedicated to this task, which is also pretty useless because, I mean, it's just exchanges a few data outside. So there are certain sensors that make sense to use with the GPIOs internal of the Raspberry Pi. There are others that make sense with this, which is extremely cheap. It's an Arduino-like. It's very simple to program. You can find already the libraries outside there that deals with loading the temperature, and then you can transmit the data from here to the Raspberry Pi. This is my suggestion, okay? You can do also with the Raspberry, but it's something that you may lose some data from time to time. You have to be ready to deal with. It depends from the application, from the sensor, and so on. But basically, if you want real time, this is a very tiny, very small, very slow also but it is dedicated. It's a single task. It's like having a thread that does only the temperature acquisition, okay? So, if instead you want to go with a Pi, I have another sensor here that is able to read these tags, okay? And these tags can give you the identity, an ID of the person who is using this. In this case, you may want to know how the peripheral works in the Raspberry Pi. I have this picture, but even better, everything that I am saying here is something that you can find on my GitHub repository, where there are a large number of tutorials. Oops, sorry. Something went wrong with the projection. Duplicate. Okay. So this repository just have tutorials with explanation how to set up the Raspberry, how they works the GPIOs, how can you put the Docker inside the Raspberry, and so on. So this is the reference that I leave you. And when you access the peripherals, you have a lot of libraries that will help you, so you don't have to bother too much with the hardware if you are not a proficient hardware geek. In order to start, and this is, I want to more or less skip this part because you will find on the tutorials, but just for your reference, you set up just the SD card of the Raspberry Pi, which is a tiny computer that loads everything on the SD. And once you boot the image, you are ready to go. You have a Linux image inside, you have many libraries, you can go with it, and you have just the need to load some things that are needed to, as a requisite, to pre-install these packages that are needed in order to run an application with .NET. There are common packages that are Ubuntu packages, basically, okay? It's nothing special. When you install these packages, you can either install .NET Core in the runtime, starting from the 2.1 that is going to exit in a few, let's say, weeks, months, let's see, okay? You also have the SDK, as I said, and it's very important because you have the command line that you can work with. And, but you can also avoid all of that. So if you want, you can just X-copy everything on a folder and run. And I will show you that. So basically, it means that you can create a self-contained deployment of your application with .NET inside the same folder, copy it via SSH on the Pi, and go. Nothing else. So the useful tools, and that's the most important part of the story, is that you need to access the Pi with a terminal. Of course, it's Linux, so you want a terminal. You want to access in order to not only to give commands, but also to copy the stuff. And I found that the best solution for that is not using the classical PuTTY or WinSCP, but Bitwise. That is a tool that you will see me using that. Because it gives you both. And so it's very practical and can easily give this capability. And then there is a tool that I published on GitHub that is very useful to make a sort of continuous integration, continuous deployment. So after you begin in developing stuff and you discover that you want to copy the files, and then you want to make a chmod to give the executable attribute to the executable, because you're in Linux, you need that, and you run the thing, after 5 times, you get bored and say, oh my God, what's that? And so I created a tool that basically, touching one button, I can deploy the stuff and automatically prepare the folder for you. So you just have to run the executable if you want and forget it. We will talk about this thing later in the last session, that is today with Linux. And so I don't want to spend too much time. But I want to show you how to create a console application, which is basically kind of service in Linux, and we also talk about this later at the end of the day, because the console application is something that you can run in automatic execution on Linux, and so it will start automatically, and also to drive the sensor here. And what you can do is just a normal console application that you will use under Windows. Okay, so nothing special, it's a main. But you add a few libraries, and you can choose between these two, but others are coming, in order to access the peripherals. So you don't have to bother about interop with the wiring Pi, which is the most common library in C that is available on the Pi. It's, and they also already provided the way to access the peripherals using this library from C#, so you don't really need anything. What's that? Okay. That is, I mean, there are these changes may be useful if you are doing interop. I don't know what happened here. The changes that in the project file here are not really required. Just if you want to use the interop by yourself, it may be useful to you to add this in order for the runtime to know that you are just running on Linux and you don't want to run on Windows the application. So let's see the deployment. And the deployment is something that you make with the CLI. Fundamentally, my tool uses this CLI in order to deploy the things on the Pi. And .NET publish is okay in order to prepare something to publishing. And -C release is basically that you don't want to publish something in debug mode, but if you want, you can. And the runtime, which is the runtime, they need to know which library include in the packages, which part of the core CLR you want to deploy on the Pi, the Linux ARM, of course. And you may opt with the self-contained true or false. It depends on you. If you want a single Xcopy and forget about everything, you can go with the self-contained, so that's the second line. If you don't want the self-contained, of course, the packaging deploying is smaller, but you require either the runtime or the SDK. It's up to you to choose which one of the two you want. Okay? Either you first install the runtime on the Pi and then you avoid the self-contained deployment, or you copy everything and don't care about that. But you always need to make CH mod. This is one of the reasons why you may want to use my tool to deploy. In order to make the continuous deployment, my tool has a configuration file that basically have several steps called action. And these actions copy all the things, prepare the command line interface with the parameters, run everything, and then deploy the stuff. But I want you to show instead other kind of code, because we will discuss later this stuff. So, the first thing that I want you to show is this. Let's say that I close the terminal because I want you to show that from the very beginning. This is the Bitwise, and Bitwise asks you to log in. Okay, I can contact my Pi. Okay, and you see I have two separate windows. One is for copying if you are if you prefer to copy with a drag and drop, which is very practical, or if you want to use the command line, you have the classical command line. Guess what my password is. Okay, and what I am doing here is going to this folder, and you will see that here we have an already deployed application that is quite long, but not too much. that have everything inside. So this is a self-contained deployment. You can see the libcore CLRSO. And you see also the debugging stuff. So you have really everything. And you also have the wiring pie that is deployed together with one of the application that makes the interop with the GPIOs. And since this want to access the camera that I have here, I have to run the application using sudo permission. So steaming, not boiling something. That's not the best option. OK, so you have seen a small delay. Why? You can imagine if you work with Java, or if you work with .NET, what is that? It's the jitting, OK? And I want to prepare to the fact that the .NET team is working on something that is able to prepare the environment with something that gives you the native bits already, if you want, and avoid the jitting part. Something that they already did on a UWP application. So you have a pre-compiling everything with the native assembly instruction so that you don't have this wait anymore, okay? And after that, I go here because I don't never forget my own okay. I have a page that is pure JavaScript, so there is no, yes, there is no Silverlight. Oh my God. And this is basically an application that is extremely simple, because on the Pi, we have an hardware encoder, and it is an H.264 encoder in hardware that can give you the data, okay, that are blobs, of course, because who want to care about H.264? I had to care to write this application. Why? Not because .NET Core cannot handle it. No. The problem is that the player that I found on the internet, it is a JavaScript player, is not able to deal with all the cases of the H.264. So I had to separate the frames. And once the frames are separated, the JavaScript player knows what to do. Okay? So I had to modify a little bit this thing. But how does it work? It is an ASP.NET Core application. Okay? And this ASP.NET application is using a package, a NuGet package, that deals with WebSockets. So the browser connects to the ASP.NET Core on port 5000, have you seen? And negotiate the WebSocket handshake, open a stable socket communication, and ask for the data. And as soon as the data is coming from the camera, it is pumped up from the server to the clients, because maybe more than one, automatically, separating all the frames with my code. It's not that hard. I will show you a little bit of the code. And once they arrive inside the client application, JavaScript, what does? JavaScript simply takes these things and decode all the bits manually and go to a canvas in order to show the current image that you have seen there. Okay? So this is working really very, very nicely. Okay, and I will show the bits here. When you go to I cannot show you all the code now. If you want to see entirely all the code, we can discuss it later. But basically, you say to the standard ASP.NET application, give me the WebSocket, okay? And then when a request comes in, I want to intercept it. And I have a context and the next middleware that is used to process the things. And if the path is WS, this is my choice. I could call it RAF or whatever it is. And is a WebSocket request, I can handle with this do client conversation async. If I don't find anything, 400. And if I don't ask for the WS, it's hello world, just to see that it works. It's a classical. I mean, I cannot live without hello world. I mean, I'm a true programmer. I feel more comfortable with the hello world. Okay, and you see a new client conversation was requested. And when you look at the code, you will see here now listening on, blah, 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 a new requested WebSocket connection. So we have exactly this kind of request. I have to deal with some initialization stuff that is done from the client side, from the player that want to know width and height. And I can set the JSON blob, and then I begin a very long loop that will last forever until there is a value, and then it will be closed until an exception is received, of course. So basically this is, yes, it continues working. You can see it was, you see, I disconnected, now it's freezed, the frame, okay? And then I can close the application. I'm quitting. Okay, this is the first option. I mean, it was really simple because I have all the bits. And I mean, it's not a straightforward application. It's something just more advanced, you see. So I don't want to talk you with a blinking LED or something like that, which is, oh my God, that's terrible. That's not IoT. I mean, we are tired about LEDs that blinks. That's really stupid. So, yeah, they are all, but they were hello world. I have total respect for Koenig and Ricci, you know. They are. So, oh, sensor server. I already forget my own name. Here is another application that is the one that deals with the door accesses. That is more complex, of course. And of course, since it had access to the GPIOs, I want to run it with a pseudo permission, you see? And it makes sense, because you have to access the hardware. And the old days when we were in the DOS, no, I believed, whoever programmed with DOS? Yeah, yes. Yes, there is an error. I will explain that. It's fine. It's not a real error. It's a true application. That's why there is an error. And you know what? You don't want this stuff to access the kernel directly in order to, and being connected to the internet at the same time. Should I mention the word security? I mean, that we know that is hard. Security is hard. And how can I be really secure with an application that is exposed to internet? There is no 100% answer. We all know. So since this is going to be run as a supervisor, I don't want the front end, the ASP.NET Core application, to be run as sudo. That would be bad, okay? So I split my application in two pieces, and it makes sense from an architectural perspective. The first one is very tiny, and the one that in the threat model, I can isolate, and I know exactly what it does. It just takes the data from the sensor and create a queue. So this is queuing something for the service that is going to process the data from the external let's say, the front end for the users. Now I have to go to another console, and I want to access the PyTerminal. Okay, that is another application. And this time I didn't deploy this application as full-fledged, but they have only the packages for ASP.NET Core, but there is no Core CLR, because I am using the SDK to run this. And so I'm using the CLI to run this application. As you are seeing, I am not using the sudo because this is my front end. Oh, sorry, DLL. Oh, yeah. That is by default. Yeah, don't care. OK, now the application is up. And as you can see, I deployed both the HTTP, but also the HTTPS. So yes, we have a secure layer between the client and the server. So I want to open this guy. And I have localhost 5443. No, sorry. Pyraf 6. Yes, 4553. I left the log very, very verbose in order for you to see what's happening in the meanwhile. And as always, we have something that it takes some time because it's cheating. And you have seen that there are a large number of DLLs from ASP.NET Core. And if it was on a virtual machine on Linux, it was a snap. But the USB, the Raspberry Pi, it have the main communication on the USB channel. Even the internal one is a motherboard that has limitations from the performance perspective. And this is why it takes more time. And this is my gate access. So basically, I have users, and you can see also the accesses to the local database, which is, by the way, a SQLite database. So our application is a full-fledged MVC application developed with ASP.NET Core that runs using a local database on the Pi, SQLite. I can even use SQL Server for Linux, not on the Pi yet, but on another virtual machine, which every time I say SQL Server for Linux, it's something, my breath changes. And it's astonishing. I mean, whoever could say that? I mean, it's incredible. And yes, I have all the modules. This is a full-fledged. I mean, I have, you see, the green, the brown, and the gray guys, but I have no black, red, and blue. So these are denied, and this is admitted, OK? And I can go home. I configure the gates. I have only one gate. There is one sensor. That is the main door. You see that it is not secure, or you know what? It's a self-signed certificate, so it's obvious that it's not recognized. I can create my own certificate route, but it takes more time. There are conditions that I can apply to filter out the door access, and then I have the access gates, okay? Green, brown, who can do what, basically, and the logs. And you know what? There is a log, which is exactly the log that we just did, we just see before. Because just before the session, Dennis was very mandatory with me and asked him, please, test your equipment before going on stage. And so I swiped one of the keys, and it got queued, of course. And you have seen that it was trying to enqueue the data on the other side. And this is the result, which is pretty good also for the demo. So thank you, Dennis. You improved my demo. And this is the result. So we can access this in different orders. Also because if the ASP.NET Core application is going to go in maintenance, you don't want to leave someone out of the door. And you want to continue to be able to open the doors, of course. And smaller is the process that cares about the gate, better is, because you have less changes to leave someone out of the door, right? So splitting into the two processes makes sense. Okay. And finally, yes, we have to see that something is going to happen by swiping, of course. And when you have denied, because this guy is denied, and this one is enabled, granted, okay, there are numbers there, and I have to refresh, sorry, but F5, and you have seen that F5 is immediate. It's not something that takes time. So if I press F5, you see the query on the database, on the local SQLite database. So this is a full-fledged application, and it's very easy to bring it on. I mean, beyond the logic of the application that I don't want to waste time in explaining here, we are talking about a console application on one side that is running in sudo to access the sensors. And on the other side, we have a full-fledged ASP.NET stack, okay, that both are running on the same Raspberry Pi and can run on every piece of hardware with Linux, of course. And we will talk about this at the very end session today, in order to communicate with each other and take everything on. If I, now, there is just 5 minutes. I have been warned, okay? And I want to shut down this guy, and this time I want to run the same application inside a container. So I don't know if you are familiar with containers, but it's extremely interesting. So I have several images here deployed. I could not deploy on stage, of course, because it takes time, it accesses the internet, and so on. So I published this PyTerminal, which relies on other images that I previously deployed and that are available from Microsoft with the runtime already deployed in. So you have everything very smoothly there. And you can see that the image is extraordinarily small. We are talking about 200 megs, and it can be even smaller on other distros. And we will talk about this later on at the end of the day. And if I run this command line, basically it says docker run, and okay, run with interactive stuff, and I want to see what happens. And I want to publish the port 5000 on the local host 5000 and the 45443 on the same port locally. So it is a remapping of the port inside the container and on my machine so that I can access. It's the gateway. It's a kind of firewall that leave me the port open, okay? And the image that I want to run is a Raffaele PTerminal. So when I run this guy, the environment of the container is bring it on, and I have exactly the same thing. So the application is running inside the container this time, with all the advantages that I can basically have multiple instances side by side, and you want to use engines, for example, to make load balancing or whatever you can imagine, or even going in production faster. Because we know with the DevOps story that testing in a container is something that can give you more assurance that everything is going to work in production. And so once you build the image, you are pretty much done, okay? So I go back in the home page. It takes a few, just because we have to git again. We go back to the logs, and you see there are no logs. Why? Because we are in the container now, and so I can still access with the denied. I can refresh, okay, and I can grant the access here. You have seen that it is working, and now we have everything that is okay. So the good part is that everything you need on the server side is there. ASP.NET Core is not just something for creating an application with web forms or things like that. We are talking about a full-fledged framework that also is suitable just for using WebSockets, for example. You have just something that gives you access to the network. I mean, today, if you have to access the network and to listen on the network, you want to use HTTP, HTTPS, WebSockets. What else? It doesn't make sense to go beyond this kind of protocols unless you have very specific problems, right? So it's like an empowered console application, and the good part that is still a console because you have nothing special to do. It's not something that needs someone else. Kestrel web server is already integrated in that. And so everything is there. And we already seen the demo. I leave you with the materials, and also there are peripherals and so on. If you want to join me in the conversation later on, after the last session, I will give you in this session, in this same room later today. I reserved the room for demos and so on. Meanwhile, as soon as I exit, otherwise Dennis hit me, I can answer more questions from you. Thank you very much for your attention. Thank you.